welcome to GTC. So I'm your today's host, Summer Liu. So today, a few housekeeping items before we get started. This session will be live streaming, and it will be made available right after the session. And then in the end of the session, we're taking a short Q&A, so you can save your questions to the end. Okay, so let's welcome our speaker today, Eran Yahav, and also he's a professor at the University of Tabnine in Israel. Let's welcome. Thank you.
All right, thanks everyone. It's great to be here. First of all, if you like my shirt, you can get one at the Tabnine booth, so please make sure to check that later. I'm going to talk about AI-driven software development, and I think I have 24 minutes left and content for 1 hour roughly, so I'll talk real fast. I'm sure that at this point you're all used to watching slides, presentations at 1.5x, so I'll try to imitate that in live. All right, so let's go. So the future of software development is really AI-driven, meaning that the entire development process from ideation all the way to a working product is going to be driven by AI, namely by an AI engineer. So what you'll see here on top is my Jira board with some application, creating a trading application, and I'll pick a Jira ticket and implement that for us. So what's running in the background is Tabnine connecting to Jira ticket, me asking it to implement the ticket, code gets generated. I started with the empty React application, and magic happens, and I get a trading app that allows me to buy and sell stocks, like a completely working app, and I can buy and sell Tesla stocks directly by writing the Jira ticket and having Tabnine implement that. So that looks absolutely great, and what happens here is really an AI-driven process in which the AI engineer, this robot unicorn, is helping me to drive the process from the Jira ticket all the way to a working product. And the AI engineer is collaborating with human engineers along the way, so the AI engineer doesn't do the whole thing by itself. But the human engineers are only involved maybe on the edges, maybe on the requirement elaboration, or in the code review, or maybe as the AI engineer finds where to invoke them, right? So that's the future. This is where we're heading. Easy to get these demos. I'm sure you've seen similar demos elsewhere, but it's really hard to get a working product. So we are not really there yet, right? So where we are today is really in AI-assisted software development, meaning that the AI engineer is helping us in a task-oriented way. Like if you want to do code generation, there's an AI engineer that helps you do code generation. Do test generation, similarly, deployment assist, code review, et cetera, et cetera. All these tasks are getting point-wise implementation of an AI engineer that is helping accelerate you, the human engineer, the human developer. And this is already generating tremendous value. In fact, if you look at the world today, Tabnine is already generating more than 1.2% of the code in the world today by serving more than 1 million users and helping automate around 30% of the code that they write. Right? So this is really just the beginning, but it's already impressive magnitude on the code being created. I'd like to talk today, in the remaining time, I'll start to pick up the pace, is how do we get from AI-driven, how do we get from AI-assisted software development to the AI-driven process, in which, again, the AI engineer is driving the process? Why isn't the demo that I just showed you, why is it just a demo so far and not something that you can take to actually generate value in the enterprise? And as we look at this question, I'd like to take a step back and remind ourselves of the fundamental theorem, as I call it, of GenAI, which means that GenAI is only useful when the cost of specifying what you want plus the cost of consuming the result is much, much smaller than the cost of doing the work manually yourself. So in fact, this theorem has nothing to do with GenAI or with AI at all. It is a theorem about delegation. It does the AI engineer actually do its work? What is the compute that's going on? And the rest of the talk, what I'd like to do is talk about challenges in communication, challenges in computation, evaluation, and maybe if we have time, talk a little bit about what's next. Probably won't reach that, but you'll have that in the slides, so you can look at that later. And I'll share some challenges and some of the lessons that we've learned in Tabnine going towards this AI engineer vision. And I'd like to start by talking about communication. How do we communicate between the human engineer and the AI engineer? When you want to do that, there's really a very short wish list of properties that you'd like the AI engineer to have. First of all, you'd like the AI engineer to be personalized. An AI engineer that has not been onboarded to your organization, who doesn't know how we do things around here, who doesn't know the environment, the languages, the frameworks, is not that useful. Second thing that we want from the AI engineer, we want it to be concise. We want it to be easy to communicate with the AI engineer, giving it only short descriptions, and want it to be easy to consume back the results. So we don't want the AI engineer to start generating lots of content that we have to review. We want the interaction to be concise and compact. The third thing, which is extremely important, is we like the AI engineer to be inquisitive. When the AI engineer is missing some details, we'd like the AI engineer to ask us, hey, Eran, or this specification is not sufficient, can you clarify the following things for me, right? Without that, without the ability of the AI engineer to push back on whatever specification you give it, it's going to be real hard to work with it. Again, in your mind, think about the AI engineer just as another engineer. You're just offshoring tasks to another location. This location happens to be in silicon instead of humans, right? But this is really about delegation, about communication with the AI engineer. Fourth and fifth here, we want the AI engineer to be reliable. Whatever it says has to be correct. Otherwise, again, it's really hard for us to recover from the AI engineer misleading us. And last, we want it to be self-aware, which is often ignored in these kind of products. We want the AI engineer to be aware of the fact that it is telling you something that is not perfect. Again, helping you review what you get back from the engineer. The AI engineer can say, hey, I got you some code, but really not sure that this actually works. It will be immensely more useful than here's the code and good luck, right? All right. So in this talk, the remaining time, which is not much, I'm just going to talk about the first 3 points here. I'm going to leave reliability and self-awareness to a different talk. You can ask me about that later. So personalization, first challenge, being personalized. Again, we want the AI engineer to know our world. When I onboard an AI engineer to my org, I want the AI engineer to know my problem domain. Like when I say a chain in Tabnine, I mean a chain of calls to the LLM. I want it to understand the solution domain. So when I say login, I mean Firebase API. When I say I want Tabnine, I want the AI engineer to know existing libraries. When I say connect to Mongo, I mean using a specific connector. I want it to know the best practices and the style, right? So really the crux of it is that we need to onboard this engineer to the organization in order for it to be effective. And the way the idea is to use a combination of 4 things, which are quite diverse, combining local, global, explicit direction, and fine-tuning in order to make the engineer aware, the AI engineer aware of the organization. I'm gonna explain in a few words each one of those. Context means that you want the AI engineer to be aware of whatever exists on your machine. You want if I have a project open in my IDE, the entire workspace, I want the AI engineer to be aware of everything that is going on there, not just the open file, not the last 3 open files. I don't want all these random behaviors. I want the AI engineer to be aware of the entire project. Second thing, I want the AI engineer to be able to connect it to the entire organization code base. So I want the AI engineer to be aware of microservices, even if they're not defined on my machine in my project. I want it to be aware of microservices somewhere in the org. I want it to be aware of other repositories, other projects that are going on. I want it to be aware of Jira tickets, Confluence documents, best practices, guides, anything that I can connect to as some sort of expert in the organization. I want to be able to tell the AI engineer, here's how things are being done here. I want to provide explicit guidance and control on what gets generated and how things are getting reviewed once they have been generated. So I want to both bias the generation, but also control the code review. Last thing is customization. I want to be able to customize the AI engineer by either switching underlying LLMs, fine-tuning LLMs, or whatever it is to make it widely aware of what's going on in the org, again, in terms of the code base. In this context of providing the AI engineer with additional information, really context is everything. We need to provide the AI engineer with as much context as we can. And it's important here to note that the generic suggestions are often a distraction. So if we have an engineer that is giving us suggestions based on knowledge from open source or general knowledge, this is not how we do stuff around here, right? So we need to generate code that is appropriate to the enterprise, to the org, following what we do around here. And really, it is a question of onboarding the AI engineer, connecting it to sufficient organizational knowledge. If you look in a general context in Gen AI for software engineering, you can go on this spectrum all the way from like no context at all, just generate unconditionally what you have learned from open source, your training data, or contextualize on current file, all open files, all semantically relevant elements, all relevant elements in the local code base, and all the way on the right here to other non-code source of information. Again, as I said, connecting to Jira, Confluence, and other things. So you want whatever the AI engineer, in the limit, you want the AI engineer to be really onboarded to the org, being aware of all the information sources that are available to it as it's doing its job. So here's an example. I have something open in my IDE, and I'm asking the AI engineer, please display a table with student scores, doesn't matter. And in order to complete these tasks, really, there are so many sources of information that the AI engineer can look at. So it can look at the open file, the currently open file, other open files in the IDE, maybe the current selection of what you selected in the IDE, compile and syntax errors, runtime errors, I don't know, other project files, project metadata, what is Git history, I don't know, what more? All sorts of other things, open conversation history, connected repositories, and the non-code source of information. So all these kind of sources of things that are available to the AI engineer have to somehow be taken into account, right, as I'm doing whatever task that I was asking it to do. Context constraint, when we look at the model typically takes some context window that is between, say, 8K to 200K tokens. That's what goes into a context window if you want to fit the model. And we have all these sources of information. So kind of I asked this question of to display the student scores, table of student scores, and I have all these sources of context going in, and I have a limited budget. I have this limited context window where even if I had unlimited context, the latency increases with the size of actually what I put in the context window, or I can trade it off for accuracy. So I can have really unlimited context, but then I get some accuracy dropping. So we need to find a way to feed all this context into the model in a clever way. And really, the context sources are competing for attention in this case, right? We need to find a way to balance it. And so the first step of any work, that's our lesson here, the first step of the AI engineer in any interaction is really to determine the relevant sources of information and how to budget them. And when you run out of budget, you would need to do something clever, either drop the source of information or abstract it in some way, right? So you need to somehow compress these sources of information and feed them into the context window. Here's how we view this and implement it based on our kind of experience. The way this is done in Tabnine, the context awareness, is really combining three elements that are shown here. First of all is local RAG. We basically do RAG over the current project in order to feed this local context into Tabnine. And so, does that work? Not at all. All right, I cannot hand wave over this. No laser pointer. So the first thing that we'll do is whenever you provide a prompt, we augment it with source of information from local RAG. Second thing that we do is augment it with source of information from global RAG, from repositories in the project. These go to augment the prompt as well. And the third thing is we use fine-tuning in order to fine-tune the universal model and create custom model based on wide organizational knowledge. So this combination of local RAG, global RAG, and fine-tuning gives us a very comprehensive view of what is going on in the organization. Our RAG uses what we call semantic memory. Okay, it uses what we call semantic memory, which means that we don't only use a vector database to look at similar things as embedded in latent space. We also have some way to find relevant semantically related entities for any question that you ask, for any interaction with Tabnine. We rely not only on similarity of vector database, but also on some semantic memory. Semantic memory is per programming language. It is aware of the semantic of the programming language, knows how to find related source of information, and that goes into the context as well. Memory, which is the standard embedding of code elements into latent space. Maybe the interesting thing here is that we're populating this vector memory by parsing the code base and extracting relevant code entities. So this is like analyzing the code in a way that finds the interesting entities to embed and actually doing multi-scaling embedding. So you do the embeddings both at the function level, class level, project level, file level, etc., to kind of get a very flexible way of getting related information in vector space. We use our own code-aware neural embedder, lightweight neural embedder, to create the vector representation. This is another important piece here. So when you look at the vector memory, there are really all sorts of design choices. I think RAG is often waved as some magical solution that is easy to create, but actually the details are much more involved than that, and getting that quite hard for, I see some people nodding in the audience, meaning that they've tried. And there are many kind of design choices here, going all the way from the way you chunk the data, like the chunker, to the embedder, how you do the pre-processing, query expansion, the post-processing, etc. In Tabnine, what we're doing, first of all, in terms of the chunker and the embedder, we're using a syntax-aware chunker, meaning that, again, we parse everything in order to feed it into the vector database, and we understand what are the relevant code entities that should be embedded. By the way, benchmarks show that using syntax-aware chunking is yielding up to 50% improvement in the accuracy of this process. We're using our own embedder. The effect is marginal when switching embedders, but they do have to be code-aware embedders, so embedders trained on code and not generic embedders that you get elsewhere. Yeah, that's just chunking syntax-aware. Some other things in pre-processing and post-processing. Basically, in Tabnine, we have another model that whenever you provide a prompt, it is doing some rewriting of the prompt, rephrasing it, and possibly splitting it to multiple queries. And we do post-processing, which is based on re-ranking and merging results from separate queries. All right, in terms of so that covers the first challenge. Second challenge is being concise, as I said. And really, the idea is to keep both the input and output short and effective to reduce the cost of specification and consumption of the results. The modalities of communicating to and from the agent could be very different. So it could be natural language, it could be code. You can be giving natural language, getting code back, giving code, getting natural language back. All of these things are valid. But what really works well is what worked well in the demo that I showed you is that we had this notion of immediate feedback. So my Jira ticket said many complicated things, but at the end, when I act application of buying and selling stocks, it was very easy for me to say, yes, this is what I wanted, or no, this is not what I wanted at all, right? So this notion of being able to make a snap judgment when I consume the result and say, this is what I wanted, is key to the adoption or to being concise. And the question is, how do you get that when the result is not UI, right? So when it's UI, you can look at it and say, yes, it behaves as I want. But if what you get is code being generated, the question is, how do you consume that? And some idea here that is still in research land is something done by UCSD folks, which is using live programming to get immediate feedback. So how it looks intuitively, at least on a hand-waving level, I won't have time to go through the details, is when you ask for something to get generated. In this case, I want to return the most frequent bigrams in a string. You get the AI engineer to generate some code, so there are some options here. And when you insert them in preview mode, and you can actually see the output, what this code, how this code manipulates a particular input. So you can play with it in live programming style. What you'll see here that I'm editing kind of the input and the output changes throughout the execution, making it slightly easier for me to consume code as it being inserted into the IDE, right? So this is a compelling idea. It's really hard to get it to work in practice. So it's really easy to make it super annoying for the developer and really hard to make it smooth and nice. So this is why it's still in research land. We played with it. I think there's still work to be done here to make it work for real. Third challenge, being inquisitive. So we want the agent to ask you questions, you want the AI engineer to ask the engineer questions, but it cannot ask too many questions because, again, this becomes annoying very quickly. If you ask me to do something and I come back and ask you 100 questions, that's not going to be super useful, right? So we need to minimize the number of questions being asked by agent. And the idea here is with active learning. So this is a really fundamental idea, and you can read more about it in this list of papers. And this comes from really the notion of active learning, in which the user is a teacher, and the agent or the AI engineer is the learner. You provide the initial specification, and then the agent responds by asking you a question. You provide answers. At the end, you converge to some result. But the point here is that by using active learning, you minimize, or the agent minimizes the number of questions to be asked. So intuitively, it looks something like this. You have a specification space. You start with some spec. You provide it. This defines really the space of possible programs that satisfy the spec. And now the agent can go back and ask you a question. You provide an answer. This restricts or reduces the set of matching programs. And you can keep on going until this set of programs that satisfy the spec is small enough for you to present, for the agent to present to the user. And really the important bit here is how to ask the most valuable or the most informative questions, right? So I'm the agent. I need to think real hard, what is the question that I need to ask to kind of differentiate points in this space? So there are high level, there are two options for me here. One option is to do prompting. So I can just go to the model and say, hey model, or hey LLM, pretend that you are a developer, given the following task, what clarifying questions would you ask? But this does not guarantee any minimality. This is just like praying, which is not hoping, which is not a super good strategy scientifically. Second one is to ask separating questions, which is generating exploratory implementation and ask separating questions between them. Again, I'm going to hand wave my way around it. So let's say I asked to write a program that adds 3 numbers. I can generate several programs to satisfy this spec. And then what I'm doing is I'm going to generate separating planes between them. And so I'm going to ask basically to separate these things, like, do you want it as a list or as 3 parameters? Or do you want to add these 3 numbers using a loop or not using a loop, right? So by generating multiple alternatives and switching and trying to generate separating plane between them, I can minimize the number of questions. If you want to look at it with a concrete example, here, like I asked it to generate 4 programs and then ask separating questions between the blue and the green one, green and the yellow one, et cetera, and you can see how these questions come into being. So just to summarize the communication part, talked about personalization and showed you a combination of fine-tuning RAG and context prioritization. Being concise is really about making it easy to make a snap judgment whether what you got is right or not. And being inquisitive is using active learning to ask the most valuable questions. Building self-awareness, and ask me later about computation and other aspects that I did not get to cover. And I think I will just stop here in terms of time. So thank you very much.
Thank you, Eran.